Hi, my name is Max Sullivan. Today we'll be talking about Raspberry Pi Lesson 6. This is a pretty exciting lesson. It's the first one um, where we don't just make a light flash, although it is an option if your program's not working correctly. But we'll get to that explanation in a second. So today's lesson is supposed to be a screen output lesson. So essentially, after we build this program, we should see different colors flashing across the screen. This lesson uses high color, as you can see from the Raspberry Pi website. There are multiple colors of color. RGB 32 being the best, true color being the second. High color, which is the system that we're operating in, low color, 8 color, grayscale, and monochrome, which is simply black and white. Grayscale, variations. 8 colors, the first two actually include colors. Low color starts to be pretty good. The image looks pretty nice. And then we're not getting to it the true color, which the image is very nice. So we're going to talk about our code for a little bit, and then I'll show you the output, which I currently have running on my TV here. So we'll start with one of our two functions that we're focusing on. We also have systemtimer.s and gpio.s if you've seen my previous videos. However, we're not going to talk about those because they're just doing exactly what they've done in the past. They're kind of a fallback. If your program doesn't load right, the light will flash. So if nothing's building correctly, the light flashes. So the first thing that we're going to do is we're going to pass data about our frame buffer. This is our width and our height, and then our virtual width we need two of both. We need it essentially is a square or a rectangle in this case. So we need two different sets of width and two different sets of height. As you can see, 2 times 124 is 2048. That'll be the number of bytes per row that we'll see on the screen. In addition, we're passing bit depth, which in the case of high color is 16. We're using 16 bits to store each pixel. It can be up to 32 because RGBA 32, so it's 32 bits to store each pixel. And it can also be 24, which uses 24, which is true color. Anyways, continuing on. As you can see, you have to check first to make sure that width and height are both under the maximum of 496, and that our bit depth is under the maximum of 32, which is true color. If they're not met, we're just going to split back out of 0, and that is the case where you have either flashing right all the way up very high, because the program just stops, and to let you know if it's going to back. But assuming that we don't have that issue, we're going to continue on, and we'll push R4 register on the stack because we need a place to store the frame address. Sorry, stack, not state. And then we're going to load the frame buffer info, which is the information from up here, into that address, passing the width into 0 and space 8. Remember, 4 bytes, so they have to be 4 bytes apart. So 0, 4, 8, 12, and 20 will hold all of our information, all in register R4. We then pass the address of R4 to R0, and move the channel address into R1, so that what we call mailbox write will have both the address of the information for our frame buffer as well as the channel that we're going to use. R0 or mailbox write takes in R0 and R1. Then we'll call mailbox read using a 1 in R0, which is the channel that we want to use. If the result of mailbox read is 0, then we'll fail. Um, or if it's not 0, we'll fail and we'll quit out of the program, which will lead to a right. But assuming it is correct, we'll pass the frame buffer to results, so that way we have the buffer to store or to show our we'll get to in a second. Mailbox.s next. So mailbox.s is actually going to pass the values that we want to see. So the first thing we have to do is load the value of this So mailbox right tests to see if these two values are equal. If they're not equal, we escape out of the program or we just quit. But if they are equal, we'll compare R1 with 15, and if we remember, R1 was our channel that we were passing in from frame buffer. If it's greater than 15, because there's only 16 possible channels, we will quit out of the program as well. So we're going to rename R1 channel here as well, and R2 will be given the name value. R2 will just take the same value that R0 currently holds, and that's just to avoid overwriting that value entirely. We want to make sure we can access it later if necessary. And then we'll call get mailbox face, which is up here, and that's what loads in the address of read to R0, or currently, because that would be the overwriting. So now R2 stores what R0 used to, with R0 now stores this value here. Then we can just go ahead and delete the alias. Sorry, this video is probably going to be a bit long. This is the first lesson we've done in this nature. So then again, moving on, we now have a loop. This loop just loads up our status and tests to see if the status is currently at this value. If they're not, we just branch back and try loading it again. If they are, we'll stop out, or we'll branch out of there and continue on. We'll add value or channel to value and store the value in value. That was a little confusing. Then we'll delete the alias. We'll then store we'll store the value of value, which is also R2, and I'm going to call it R2 right now, into the right field, and then delete our aliases. So that was mailbox write. We'll then go into mailbox read, and mailbox read returns the current value in the mailbox addressed to a channel, where mailbox write writes values into channels. So the first thing we'll do again is compare that R0 is within the possible 16 different values that we can have for our channel. And if it's higher, we'll just quit out of the program. If it's not, we can continue on. We'll pass the value of R0 to R1 to ensure that the value is not overwritten again. And then we'll really focus on the loop here, which does a lot of what the last loop looked like. It loads the status and tests to see if the bit is 0. If it's not 0, it loops back to the same loop and could potentially be stuck there. If it is, we read the next item from the mailbox and continue on. We then have to check to make sure that the mail that we read was actually the one that we wanted to do. So that's what we're doing here. We're combining the values that we're getting and comparing them to the channel that we were trying to receive. And if those values aren't equal to the channel that we were expecting, we don't have the right mail. And if it's not the right mail, we'll loop back up and try to get the right mail, or we'll be stuck in an infinite loop, so that way we're not displaying the wrong thing. So finally, we'll go over to main, and we'll look at this really quick. And so here we're passing, the first thing that we're doing is setting up the frames into our into register values. So we're passing R0 the frame width, R1 the frame height, or the buffer height, and R2 the bit depth that we expect, 16 again being the bit depth for high color. We then call initialize frame buffer, which was over in framebuffer.s, and is actually what sets and checks to make sure that our frame buffer is within legitimate constraints. If it's not, if that fails, we'll this is where we'll flash our light to say that our frame buffer is too big, or expecting too much out of us, and that can't happen, so we'll just air out. So we'll flash the light, and then we'll just stay in this air state, and nothing will happen. If there's no error, though, we can move on and give the frame buffer address to R4. We then load the frame buffer, or I'm sorry, load the frame buffer pointer to R4. We then load the frame buffer address into R3, and here's where we actually start to display our colors. So we give R0 the alias color and R1 the alias Y, which is our frame height. It's going to get our frame height. X is then going to get our frame width. And then we do our first draw pixel loop, and we start to sub from X by 1, which is essentially saying skip or go pixel to pixel. And when we get to 0, we've reached the end of that string of pixels, which means we've reached the end of the row. But if we're not at 0, we'll just keep drawing the pixels as we're going across the row. Once we draw a full row, we go to the next line, so we subtract 1 from Y. So say we did this the first time, we get down to 0, then we go to 7, 6, 7, so that way we can do the colors, do a different color on the next line, which we're incrementing here. And so we'll be back into here, we'll draw the next row in a different color. But if we're not at 0, and then if we get to 0, which would be our last line, because Y is essentially our height, so it's kind of like we'd be at 0, we'd just be at the bottom of the frame buffer. We're done, but if not, we continue to draw rows. And then once we are finished, we just skip back out to render, which allows us to run this whole process again. So, we'll really quickly, because I'm already at 13 minutes, show you how we build it, and then it's already running on my screen, so we should be able to get through that pretty quickly. So we'll switch over to our Yagarto folder, so cd c Yagarto user. I'm going to clean it up because everything's currently in there. We'll make our build directory because we had to delete that from the makefile process, as we kept encountering the same error where it was trying to rebuild the build directory. Every time it would try to build the next file, because now we have 5, where in lessons 1 and 2 we were only dealing with a main.s folder, or main.s file. And then we'll go ahead and build it, and you can see we're successfully building. We get our kernel.image. So I already posted the kernel.image into our Raspberry Pi, and it's actually running on my TV already, so I will show you the output. So you can see right now it's flashing different colors across the screen. Sorry, this is a little hard to do while standing. So that's our output. Now it's Pi lesson 6. Anyways, thank you for watching.